So first of all, altitude to the hypotenuse means that we've got, in this case, a line drawn to the hypotenuse that is perpendicular to it. That's the altitude. And so we have two forms of it. When the altitude value is either asked for or given to you, then the proportion we set up is that the altitude to the hypotenuse is that geometric mean. Remember, geometric mean means it goes in both of these spots in your proportion. Then we set the two split sides in the other two spots. We do our cross multiplication. So x times x is x squared equals 12. Now we take the square root of both sides. Technically you should get a plus or minus, but since it's the side of a figure, we don't need the minus, so we're going to just do the square root of 12. Then you got to think about what perfect square goes into 12. Well, that's 4. 4 goes into 12 as a perfect square. 4 times 3. And so when we multiply those two, we get 2 square roots of 3 as our exact answer. Now, if I ask you for it to a decimal place, you just go back to the square root of 12, do that on your calculator. If I take the square root of 12, I get 3.464. So if I say to the nearest tenth, you just say about 3.5. But only do that if I say round it rather than giving me this is the exact answer. Now this problem, when we don't have the altitude to the hypotenuse, instead, notice that's not a requested side and it's not given to us. Instead, we've got to use the one where the leg of the triangle is the geometric mean in that case. So in this case, when I set up my proportion, that x is going to be the geometric mean, and it's going to be between the whole hypotenuse, which is 10 plus 8 is 18, and then the split side next to it, which is 10. So now when I do that proportion, I do x squared equals 180 when I multiply those. Take the square root of both sides, and let's say this time I say round it to the nearest tenth. You would then just do square root of 180 on your calculator. So I'm going to do that, square root of 180. And I would get 13.416, so I'd say about 13.4. But if I say do it exact, let's look for a perfect square in this. Well, let's see. I can see that probably 9 goes into this. So let's make this the square root of 9 times the square root of 20. 20 times 9 is equal to 180. Oh, in 20, there's another perfect square. Let's split out 4. So you get the square root of 9 times the square root of 4 times the square root of 5. Okay, 9 times 4 times 5 gives me that 180. Square root of 9 is equal to 3. Square root of 4 is 2. And then we got the square root of 5. So I get 6 square roots of 5 is the exact answer. That is the algebra review type of work that we did of being able to simplify those using geometric mean, which also we've called before the mean proportional. All right, let's do some other problems. Now, on these other ones, I'm going to kind of pick and choose. I'm not going to do all of them. So on this section, I want to go down here, and I want to look at this sine, cosine, and tangent part for angle G. These types of problems, when you look at them, to do sine, you're just looking at this information here and saying for sine of angle G, that's going to be the opposite over the hypotenuse. So for sine of angle G, you get 30, the opposite side, over the hypotenuse, which is 50, which reduces down to 3/5 as your answer. That's all you need to do when all the sides are given to you in a right triangle and you're asked for sine, cosine, or tangent. So cosine, SOHCAHTOA, the cosine is the adjacent. So from G, the adjacent side's the one right next to it, that's 40. We put that over the hypotenuse, which is 50, so you get 4/5. And then lastly, the tangent is the opposite side, 30, the adjacent side, 40, so we get 30 over 40 which reduces down to 3/4. Now let's do this word problem. This is a angle of elevation problem. So Josiah's here, he's actually on top of the observation tower, okay? So he's standing up here, and which is 50 feet from a monument. So let's go 50 feet here. Looking at the monument. When he looks at the monument, the angle of the elevation to the top, so this monument is up here. The angle of elevation to the top, from where he's looking, that angle is equal to 25 degrees. The angle of depression from where he is down to the bottom, so down here, that angle is in this case 45 degrees. So notice, since this is 50, so is 50 right here. That's 50 on that side right there for this length all the way to the monument, okay? We want to know how tall the monument is. Well, I'm going to do this in two parts. I'm going to do the angle of elevation problem, which looks like this. This triangle has an angle of elevation of 25. It's got a bottom side of 50. And we call this X. So this part of the monument from here to here is X. So let's go ahead and calculate that. This is the opposite and the adjacent. So tangent of 25 is equal to the opposite side over the adjacent 50. Tangent of 25, let me do that on my calculator let's do it to 4 decimal places. Okay, so I'm going to go with tangent of 25. That number to 4 decimal places is 0.4663 equals x over 50. Now, how you solve that equation, you get rid of the 50 in the denominator by multiplying by 50 on both sides. So I get x equal to 50 times, 50 times 0.4663, and that number is 23.315. All right, now let's do the other problem. Notice I've got a triangle here that I'm talking about. Okay, so that triangle, I'm going to set up here. Okay, so its angle of depression from there down to the bottom. We're looking for this side here. I'm going to call it Y. So this from here down to here, I'll call Y. Part. So Y there, this angle is 45, and this side up here is 50. Notice I can use this angle in this angle of depression problem because I'm not dealing with it at the bottom. I could set it up down there too, but this is the actual triangle I'm dealing with in this problem. So let's set that up. Again, we're dealing with opposite over adjacent. So let's do tangent of 45 equals the opposite side, y, over the adjacent side, 50. Tangent of 45, let's do that on our calculator. Tangent of 45, oh, that's very nice. That actually looks, ends up being exactly 1 over 50. So multiply by 50 on both sides, and you get y equal to 50. So how tall is the monument? We take 50 plus the 23.315. Let's say we'll round the answer to the nearest, in this case, foot. So 50 plus 23 gives me 73 feet for the height of the monument. So setting up 2 different problems. All right. And again, you can pause that if you want to look the work over a little bit, to write it down, things like that. You can pause the video. let's go on and take a look at the next set of problems. On this one, what I'd like to do in these problems is looking at this down here. It says find Qn in simplest radical form. If Q is a right angle, QM is 18, so this would be 18 on this side, and MN is equal to 24. So it asks us, given those two sides, how would you find out what QN is here? I'll call this X. Well, here you might be tempted to use a trig function, but a trig function involves the angle to get the sides and tie those together. Here, if we just want to work with the sides, just use the Pythagorean theorem. So we go with x squared plus 18 squared equals the hypotenuse squared. Let's get what those values are. So 18 squared, so I've got x squared plus 18 squared is 324. 24 squared is 576. Okay, so I subtract 324 from both sides. So 576 minus 324 gives me an answer of 252. And let's do this one to the nearest tenth. Let's take the square root of that. I don't need the negative because it's a side of a triangle. 252. That gives me x is approximately to the nearest tenth, okay, as 15.9. Now, if we had to do simplest radical form to get the exact answer, just to practice that, we could take this 252, separate it into factors, so we get 252 divided by 2. Let's see, 252 divided by 2 gives us 126. I can then divide this by 2, and that would give me 63. And then I divide that into 3 times, in this case 21, which is 3 times 7. Every time something is repeated here, those create a perfect square. So that's the square root of 4. These two together give me the square root of 9, which is a perfect square. And then I've got this 7 here that's kind of off on its own, which is not a perfect square. So 2 times 3 times square root of 7 gives me 6 square roots of 7 as our simplest radical form for that. All right, and lastly, here's some, remember you could stop it if you want to take a look at the work there. Let's look at using special right triangles and solving these problems. So on this one, I'm going to set, since it's a 45, 45, 90, I'm going to draw right next to it my special right triangle, which is 1, 1, and then the square root of 2. Let's set up a proportion. If we're trying to find x, I'm going to put x, which is a side opposite the 45-degree angle. So since this is 45, I'll put it over 1. That equals our hypotenuse, so I'll do 24 on this one. Since I started with x on top, I'm going to start with 24 here, and put it over the square root of 2. So now when I solve that, I do my cross multiplication. So x square roots of 2 equals 24 times 1. Divide both sides by the square root of 2. You get 24 over the square root of 2. Practice our algebra. What we want to do is not have a square root in the denominator. So to get it in a different form, but the same answer, multiply by the square root of 2 over the square root of 2. You get 24 square roots of 2 over the square root of 4, which equals 24 square roots of 2 over 2. Now, since both of these are outside of the square root, they can cancel. So we can cancel this 24 with this 2, leaves us with just a 12. 12 square roots of 2 for an answer. Okay. And lastly, I'm gonna go ahead, since this one is another one where you just use the Pythagorean theorem, because you're given two sides, find the third. Pythagorean theorem, we just did an example like that. Let me do this one using our trig functions. So if we're trying to find x rounded to the nearest tenth, we've got the hypotenuse. We're trying to find the side adjacent to the 68. That means we're doing cosine. So we're going to do cosine of the 68 degrees equals the adjacent side x over that hypotenuse 9. Let's figure out what cosine of 68 is to 4 decimal places on our calculator. Cosine of 68 gives me about 0.3746. Okay, that equals x over 19. Now to get that 19 out of the denominator, you multiply by 19 on both sides. 19 times 0.3746 gives me an x value of 7.1174, so rounded to the nearest tenth is 7.1 for an answer.